Okay, let's take a look at binary trees, binary search trees, and the code. So I'm going to use a lot of the code from the lecture in this demo. Let's open up Visual Studio. Okay, and this one is going to be on trees or BSTs. So basically, create a new project, and it's going to be a console app, and we're going to call it BST. I guess we'll just call it that, BST, and we'll put it on desktop and create. Okay. All right. So open that up, and what we're going to do is we're going to start implementing all of the trees code that we have. So let me, I can clear this one out. This is BST. Well, we can call it main.cpp. Main.cpp. This is the main. This is the test main, right? This is the testing. This is the main for testing main for the BST functions. Now you're going to use these functions in the project, right? But this is the testing main to test those functions. So once you've tested, okay, these functions, don't make any changes to them. You're just going to port over those functions to your project if you're part of the project. Okay, so this is main. I'm not going to use C++. I mean, we're using C. In main, we're probably going to need standard IO, standard library. Okay, so stdio. So 1 second. Let me go here. We want it include standard IO.h, right? We want to include standard library. These are things that you probably need. We're likely going to need to process strings in our BST, so we might as well include, let's say, string.h. Okay. What we're going to write, let me go here. We need a couple header files. We need to define our, okay, this is our client, right? This is our client. We need to define our interface and our implementation. Okay, so in terms of our interface, we need to define a couple things. So one, we need to define the nodes in our tree, okay, and we also have to define our functions in our tree. So what I'm going to do, I'm going to define the node in a separate file than my functions. Okay, so let's do that. I'm going to call this tree node.h. Okay, so this one is a node. So this is tree node. Then I want to have the tree functions. You could do them all in the same file, but I like to keep them separated. So tree, we're going to make them tree func.h. Okay, and add that. And then we need our tree functions.cpp. So in here, I need to add new item tree func.cpp. Oops, what happened? And I don't want a header. I want this one. And I need tree func.cpp. Okay, so we got tree func.h, tree func.cpp. We've got our main. All right, so we need tree node. Let's start with our tree node. So we can leave the pragma once if we want. So let's do our standard. This is our standard. We want to label comments. So this is tree node.h, okay, and this one is the interface for the tree nodes, tree node structure in the BST. Okay, you can put your byline, okay, in here. Let's do the same thing for all of them. So we have tree node, tree func. The reason why I put all these headers here too, because if you copy and paste from these files into a common Word file, because when you submit your code, you want to separate out, because it might all be in one file. Okay, so anyway, this header will help to separate it. So we have tree node, we have tree func. So it's for the tree functions in the BST. Okay, and then I also have tree func here. Paste. So this is tree func dot cpp. We could use, and this is the implementation. Implementation of the tree functions for the BST. Okay, you can, we can go here, save all. Okay, so again, I just want to get everything nice and all started, everything's up. So let's start with, the simple thing is we need to define the structure of our nodes, okay? And this is something that I already gave you. It's going to be very similar to those that we saw before for the linked lists, okay? So first thing first, we have a length, right? For the, because we're using strings, right? Okay, we're using, or you can have a define here if you want. I'm just going to use the constant. But the idea here is that the strings that we're using as the keys for our nodes in our BST, it's going to be, we're going to use the quotes, okay, from the fortune cookies file. So that's the first thing. Then we have to define the structure. So what I like to do, I like to put my aliases for my type def first. Okay, so I want struct item to be called item. I haven't defined item yet, okay, but I want to already put the alias here. Same thing. Type def struct. Now I'm gonna have the BST node. So BST node, okay, as node, okay, and then I need a pointer to that. So type def. So struct. So I want to make struct BST node pointer, a pointer to a BST node. I want to call that a link, okay. So these are just aliases for all of these things. Now I haven't defined struct BST node or struct item yet, and I'll do that right now. So right now I want to go define. I want to define item, what I called item. This is the content of the BST nodes. Okay, so struct item. I have to define struct item now. Okay. All right. So the first thing is we have a buffer of I length. Okay, it can hold a maximum of 140 characters. So I might as well just do that right now. I need a sender ID, so all of this is coming from the project. Okay, this is supposed to help you with the project. Int, then receiver ID, right? Sender, receiver, int priority. Okay, int seek number, sequence number, and then I don't know. I'm just gonna put, this is a placeholder info array, which you can use. I'm gonna just give you 15. Okay, this might be useful for project. Okay, so this is what we have for item, and you can change this at any time. What I really care about in terms of the assignment is this guy right now. Okay, this buffer. Okay, that's where this is gonna be the key for the BST. This is I should go like this, key for the BST. Right, this is the key. I should put it in quotes, right? These are the keys. Okay. All right, and then I have to define struct BST node, right? So I need struct, and then BST node. I have to define it now, right? So what does it look like? I have item. Now I could call this data, message, whatever I want. I'm just going to call it the message because this is the message for the project, right? So this is message dot buff contains the key, okay, which is a quote from the fortune cookies file. Okay. And then we have the left and right links, right? So link, and then we have p left, right? So this is left subtree, and then link p right. Now I define link up there. P right as the right subtree. Okay. Control S to save. Okay, so I already said what link is. A link is a pointer to a struct BST node. So this guy's a pointer. This guy's a pointer to a node. Item, I already defined it up here. I defined the alias up here, but struct item I defined, and then after I define the alias. Okay, so all these are connected. Everything is defined properly. Control S to save. So now I have my nodes. Okay, so the next thing I need to do is define. I need to say, okay, what are the functions that I need to implement a BST? Okay, and I'm going to put them as my header. Okay, so what do I need? First thing I need to do is I need to include the definitions that I just made, right? Tree node.h, right? Include tree node.h, okay? Because I'm going to be using those data types. All right, now I'm going to implement give the function prototypes. Okay, so and again, these are all coming from the straight from the nodes. Okay, so and I explained them before. So what I'm going to do, I'm just going to copy and paste these definitions from the nodes. Okay, so I have control copy. So these are the function prototypes. I've gone ahead and given you these. I just put some comments on what each of these do. Okay. Now you may want to have a get root function as well, and I've done that. So I'm actually going to do that here. So get root void. I think it's going to be useful, even though we have these other functions. You might want to use the get root function here. This is returns a pointer to the root of the BST. Okay. So what I'd like you to do, just maybe pause the video for now and copy these. You can even copy the comments here if you like. Copy these. These are straight from the notes. Okay, so we're going to implement these as well, straight from the notes. Okay, so save. Make sure that it looks exactly the same. Pause the video if you need to. And next, what we're going to do is we're going to move on to the functions themselves. Okay, so we're going to go over to the implementation next. Okay, so we're done with the two headers. So we're going to move over to the implementation files now. All right. So the first thing we need to do is we need to include the two headers. So include, we need tree node.h. Okay, so that's the first one. We need treefunc.h. Oops. Include tree functions. Okay, Control S. We need our standard AO, standard library. Let's do that. So we need wrong. Okay, standard IO.h. We need to include standard library.h. We we're going to need the strings because that's how we do our quote. Our quotes are strings, right? So we need string functions for strcomp, right? String.h, and we're going to need to, so when we build the BST, we allocate memory for a node. So we're going to need the malloc include, and we're going to say malloc.h. Okay, Control S. Okay. All right. Now, what do we need to produce? We need, okay, so these are the includes. Now we have private variables, and then we have our function implementation. So here are private variables. So these are variables that are only going to be accessible by this particular file, by treefunc.h. Okay, and then we're going to have our function implementations. Okay, Control S. So what are the private variables? Well, the root. So static link root. Okay, this is the root of the BST. Okay, so why static? Static means to this file. Okay, limited to only this file. So no one else. Main. So bst.cpp or main here. Oh, I should have changed the name to main. Rename to main.cpp. Okay, I don't know. I don't need this. All right, save. Okay, so right. So main is not going to have access to the root. The other thing we also want is a some way of identifying a null item. Okay, I remember so this is going to be something, an item. We're going to call it null item, and it's just going to be a null item. We could, right? This is the leaf, right? To indicate that a leaf was reached. Okay, so this is it. You could actually, as part of a null item, you could give it a string, right? Say not found, right? Item not found or something like that. You could say leaf has been reached. Because in a BST, we're looking for something, right? We're searching for something. And you know, if you reach the null item, you reach a leaf, that means that your search was unsuccessful. Okay. All right. So those are the two private variables. The next comes the function implementations. Okay. So there's a couple of them. There's the new one. So this one, it's create a new BST. So we're going to go link. This is the new function. This creates a node, right? So you pass it an item, and it creates a node. We have link left and link right. I spelled it wrong. Okay. And then we're implementing here. So that's one, right? And here I could put a comment here to say this creates, right? Create a new BST node. Okay. So that's one function. I'll implement it in a second. The next is to initialize the BST. So we got the void. We got void. Actually, what I could do, so I don't have to retype all of this, is go into treefunc.h. Basically grab, right? Control C. I got these already, and then paste them here. And then what I want to do is delete this guy. Open bracket. I know I can't put the close bracket because I got the comment there, but I can do this to save myself from having to type so much. Okay. And the same thing goes here. So open, take this guy out to there, and then I can close it there. Just save some typing a little bit and leave the comments to be the same. You can put make your comments whatever you like, right? Okay, so open there. And keep going here. Same idea. So remove that. We'll implement these guys in a second. You can see that as I make them, the green underline goes, right? Okay. Same thing goes here. Okay. We have the count function. These are the utility functions, height and count, that I gave you in the lecture. And then get root. This is one that it's just going to return the root, just in case we want it. I know I used it before. You don't really need it if you're using these other functions, but it really depends how we want to implement things. We might want it. Okay. So the new, we have basically we need to. This is going to create a link, pnew. Okay. Well, we're to what we're making now. So we have to cast and then malloc memory for a new node for size of, and then we pass it's the node, N-O-D-E is what the data type that we defined. Okay, so this gives us a pointer to the node that we create, and then what we want to do is store in pnew, okay, in message. Okay, it's right there. See, it even tells you, so you know you're correct if right. So this is a pointer to the new node, and then what it's pointing to, it's the actual item, the message item. We're going to store in there the item that we passed. I did the wrong. You see, item here. I forgot to put item. Okay, there we go. That's why it's colored funny. All right, so that is good. All right, so we're putting the item that we passed. So this requires that you have an item to put into the node, right? So we put the data in, and then what we say is we assign pnew, okay, p left to left, right? The link that we passed to the left, and pnew p right to the right. What we passed when we created when we created, it's usually null because it doesn't point to anything. And then here we return the pointer to the new node that we created. Right? That's what he returns. He returns a link, and pnew is the link, so we're good to go. All right, initialize the BST. We set the root, which is the private variable, equal to new, and then we needed an item, right? We need an item that is null, and then the two null pointers, because it's empty basically. Everything is empty. So this creates a new root and initializes the BST to an empty BST. All right, BST search. Again, this code was given to us. We have link h, and then okay. So we start at the root. Usually we pass the root, and then we're looking for a specific key. So we have for the actual string is RC. This is our string, and it's going to be a recursive function. So if we need the terminal condition, h equals null, right? Then return null item. Okay, so we're doing a search. If we get to the bottom of the BST, we don't find it. We don't find what we're looking for. Then we stop. Right? We return nothing. This guy's got to return an item. The item's going to be null, and the string that I put inside null item here is going to be basically returned. It's going to pass that, and we're going to know that it wasn't found. Okay. So here, what else? So now we have to go left or right. Right? So RC is equal to stir comp. Actually, RC is not the string. It's It's the result of the string comparison, right? SZ key, the thing that we let me see something here. The SZ, we're doing the SZ search key. I'm just gonna make this because I don't want to type all of this. Let's call it SZ key. Okay, so I'm gonna pass SZ key, and then I'm gonna compare that with what I store in when I reach the node. Okay, there's a message, so I can click on message. Okay, and then message has a buff, right, pointer. Okay, and so we're comparing. This is a pointer to a string array. This is a pointer. That's what strcomp gets. 2 pointers to 2 strings, and we're comparing them. If it's equal to 0, then they're the same. Less than 0, then the one on the left is less than the one on the right. If it's the other way, then the one on the left is greater than the one on the right. Okay, so you go left or go right in the tree. All right. So now what we do? So we got the now we've compared the 2 strings in RC. So now, if RC is equal to 0, then we found it, right? Return H. That's the item, right? H. This is the message. This is the item itself, right? Return the item. Okay, that's what. So that's what we found. Now, here's our recursive subcalls. I'm going to put that here because I want to. So if RC is less than 0, then we're gonna go left, right? So then we return, and it's a recursive subcall, so it's calling itself BST search. We gotta put HP left because we're going left, and we also have to pass the key that we had there, SZ, and it's a capital K. That's why it's not matching. Okay, so we go left. This is go left, and then else we're gonna go right. Okay, and I should just, I'm gonna make it a single line else compact. Just do this. Return BST search, and then we're going HP right SZ key. Done. Okay. Control S to save, and that's it. That's all for the search. And then here we're going to go to search. We're basically going to return. This is the public one. Return BST search with we start at the root, and then we pass SZ key. That's it. See, we're when we search the BST, we're just going to pass. We're just looking for a string. We don't have access in main to this, right? To the root, unless we use get root. We could. But anyway, we'll see what we can. But we may want to test BST search and BST insert. So that's why I put the get root function there. All right, so let's go to BST insert. Again, all of this is coming straight from our notes, from our lecture notes. So let's go. So int RC, and then if H is null. Right? If H is null, then so wait a minute, we're in BST. Okay, so if H is null, then we return. Okay, new. We pass item. Okay, that's the item we want to insert, and then it's a leaf, so it's null. No, the left and right, they don't point to anything. They're both null. Okay. So that is this is the terminal condition, right? This is when we found. You can comment this out. Then what we do is we compare RC. So we say RC, and we're going to do the same thing because when we insert, we have to still go down the tree, right? So we have to strcomp or string compare, item dot buff. So we're going to look at what we want to insert. Okay, the item that we want to insert, its actual string with, as we go down the tree, we're comparing, right? Item message dot buff. Okay, so we're going down the tree, we're comparing the string that we want to insert to the string that belongs to each of the nodes as we go down the tree. So that's what we're going to do now. So we're going to go, this is our recursive subcalls. Recursive subcalls for traversing the tree to get to a leaf, right? Because we got to insert it at a leaf, right? So if RC is less than 0, right? Then what do? Then we have to insert at, we're going to go left. So H, right? H is P left, right? Equals, and we're going to recursively call BST insert, and we're going H, we're passing it what it's pointing to, P left. We're passing the left node in, and that becomes the new node where we call BST insert on, and we're searching for, or we want to insert item, right? Okay, so this is a go left. I could put it here, but anyway, you guys can add that comment. All right, and then else, right? We could put this all on one line, right? This could be a one-line if, and then we have an else, right? And the else go right, right? Else we could do this. H dash P right equals BST insert H P right item. That's it. Okay, so this is one is go left, the other one's go right. Okay, so that's, and then at the end, once we're done, return H, right? Because why? Because once this guy is created, right? You return, so with that BST call, this will return a pointer to the new node that you created, right? This will return new. This returns a pointer. So if it's the left or the right, let's say we reached the leaf, then you need to return that pointer so that you can connect to the left or right arm of the left or right child of that leaf that you're attaching the new node to. Okay. All right. Now with the insert, we're basically going to so in insert we basically say that we're going to call BST insert, right? So the insert basically is going to give us a pointer to the root. So we can say a root, right, equals BST insert. We pass the root, and then we say the item that we want to insert. Okay, so whenever we call insert, okay, it's not returning anything, but we're basically saying, because BST insert keeps returning, it's a recursive function, keeps calling. It's going to give us, I mean, you can return anything, but you're inserting, it doesn't return anything, but you're inserting at the root starting at the root the item that you pass here. Okay, now we have our utility functions, BST print, height, and count. Okay, so let's go BST print. So BST print if, okay, H is null, then just return, right? We reach the leaf. Okay, I should put these guys should all be at the same. All the comments should be at the same level. Okay, I hope I have them all. They should be aligned. It's professional that way. Anyway. Okay, let's go to the bottom here. So BST print. All right. So we reached the leaf. Then what we do, because we're going to print in order, right? Private print function called by print. It's in order traversal. Just to remind you that it's an in order. These are the recursive subcalls, and basically it's BST print. We go H P left, so we pass that node, right? And then because we're going left, center, right? And we have a print F because that's what the center is, right? And this is what we do. It's going to print something. It's got to do something. So we can say the key percent S, and then we go \n. Okay, what I should do is, let's see. This is the string. Okay, so this is the key. Put it all on a new line, and then I have to output message dot buff, because the key is the string, right? That's what we're printing. And then we do BST print copy p right. Okay? Remember, left, center, right. This is in order traversal, right? Left, center, and then just to remind you. Okay? That's it. That's all you need to do there. Height and count are also similar. So we say int, and then this is the left side. All right, and then right h, the height. These are two integers. We need to, because it's recursive, we need to do the termination, the terminal or base case. So if here's h is null, right? Return negative. Here, I should do it like this. -1. Okay, this is reach the leaf. So this is base case, or terminal base, or terminal condition reached leaf, right? Okay. And then we have our recursive calls, right? So we have our recursive sub calls. So here it's I left equals height h p left, right? I right. So we recursively, I left h. This is the actual variable. Is equal to, we call height again on h p right. Okay, so we're checking the left and the right, and then we're saying which one's greater. So if I left h is greater than we're taking the greater of the two, right? Then we return I left h, and we add the 1. Right? Okay, else return we're going to return right. I right plus 1. I right h. Okay. Right? So we have our recursive subcalls. That one was relatively simple. Okay, and then we're at count. By the way, if you're having any trouble with understanding these functions, in the notes, the PDF, I do explain them in another way, other than in a slightly different way. What am I doing? If not count. Sorry, I'm talking and and typing at the same time. It's hard to do the... So, count. If h is null, this is the terminal condition, then return 0. Okay, this is our base case, right? And then otherwise, return. Now we have our count. We're gonna go left and right, right? P left plus the right. So we're counting the left and right branches, and then bringing it all together recursively. P right, right? And then we have to add the node that we're on, right? We have to add that to the total. Right? These are the recursive calls. It's really that simple, right? This is your node that you're on, and then you count everything in the left subtree, everything in the right subtree, and you're doing it at the same time. Recursion, you get to the end. Once you get to the base case here, this is your base case or your terminal condition, right? 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 Then you add this one. This one will return an actual number once it hits the base case. This one will return an actual number if it's the very last call, and then the previous calls to count it'll unfold backwards until you get to the first call to count, and then you actually get the number, the total number. Okay, so that's your count. And then finally, I have this get root function. I may or may not use it. It's just return root, and that's it. Okay, so these are my functions. Now what I have to do is make a main that is able to call these, to test these functions. So I have standard IO, standard library. I have string. I need to include tree node and tree func in here as well. So include. I need tree node dot h. I need to include. It's probably just good practice. Tree func dot h, and that's it. Right? Because this guy's going to bring in tree func dot cpp. Alright, so int main, and I'm good to go. So what do I need to start? What do I got to do first? Well, I want to use the BST, so I got to initialize it. So BST init. So first thing I got to do is initialize the BST. Right? I need an item, because whenever I make, new requires an item, so I need a pointer to an item. P, I'm going to use defensive programming here, so set it equal to null. So this is an item. I need, let's see, I need a buffer. Well, you know what? I'm going to need a for loop. So I need a counter. And so that's a for loop. I'm going to be generating a number of nodes. So how many nodes am I going to, right? So these are two integers that I'm going to need. And do I need a buffer? Well, what do I want to add? Oh, I need some sort of string to add to... I want to add a string. What am I going to test it with? Okay, look, I'm going to use a string. I'm going to use like A, B, C, D to test this tree. Okay, to test where things are going to go. So let me make an array just for testing. Let me make it 4 for now, just for testing. I don't need that many parts. So first thing is get input from user. So printf, I'm going to ask the user how many nodes I want to put into the tree. BST, how's that? Question mark. Always put it on a new, you never know. Like this, go like this. You know what? \n. It's a question, and now I need an answer. So we're gonna say, let's see. All right, let's protect. Okay, while if I want to use scanf, you know what? I want to use scanf, but Visual Studio doesn't like when I use scanf. Okay, let me start. Let's say, okay, while scanf, you can use _s if you want, but I'm going to be old school because I might want to run this in Linux. Okay, while it does not equal 1. Okay. All right. So basically, we need a number, right? So we're going to say printf. So this is an error, right? So here we're going to say, please enter an integer. Exclamation \n. Okay. And then while we gotta get out of the get car does not equal \n. Okay, because you gotta get, if somebody pushes enter, you don't want them to do that. Okay, so how many would you like? So let's do this. Control S, and this guy's got to return something. 0. Okay, before I do anything, I want to test. I want to test everything. See, just make sure everything compiles. Now, what's it gonna? Doesn't like what? What doesn't it like? No, tell me what the problem is. Where's the problem? It says scanf may be unsafe. You know what? Just do this guy. Control C. I'm just gonna do it right now. So I'm gonna say define, and then like that. Control S. I'm gonna use scanf. What else is the problem? Unreferenced local variable. That's fine. That's just a warning. Buffer is unreferenced because I haven't used it yet. All right, that's fine. This should now compile. How many nodes would you like to enter? I don't know, let me put E. No, enter an integer. Put 4. Now it should enter. Okay, good. All right, because if somebody puts an enter, it should just keep asking for an integer. All right, perfect. So we have some defensive programming going on here. All right, the next thing we want to do is fill the BST. All right, so we've now said, okay, this is how many we want. So now we know. So we're gonna fill the BST because we created the BST. So now we have a for loop. I starts at 0. I is less than. We got num, right? Num is here. So I less than number, and then we need to go I plus, and open up. All right. So every time we make, we want to put an item, we need to create the item. So P is the item. We need a pointer to an item. It's got to be cast to a pointer to an item. We need to malloc space the size of an item. Okay, and then right now we could print. Let's see. Let's go. So we're going to tell the user, okay, this is what I want you to do. I want you to enter something for that item. So we're going to say item, and then %d. Okay, like that, and then I. Okay, but we are, okay, that's fine. So we're asking them to enter a number or enter something for that item. All right, and then we scanf. All right, and we're scanning a string of some sort, %s, into buffer. Buffer is only four characters here, so we got to be careful. We're not going to put too much, but anyway, this is just our test. And then what we're going to do, we're only letting them. I only want to let them. I don't really need 4, but okay, let's just leave it. What I'm going to do is I'm going to say buffer at 2. Set that equal to the string termination character. Okay, because I want to stop at. I just want to compare one or two characters here. Okay, so all right, buffer 2 is, so I have up to 2. All right, then what I got to do is I got to go stir copy p. Okay, I got to copy what's in buffer. Okay, to p.buff. Okay, so and then I call the insert function, the public insert function, and tell it and give it what p is. Okay, what p is pointing to. I'm dereferencing p. I'm giving it the item. Okay, so let's go through this again. So what am I doing? I'm creating an item. P is an item. This is a pointer to an item. So when I insert is expecting an actual item. So I need to dereference my pointer. Okay, but what am I doing? I'm okay. So for every item that I want to insert, okay, I need to make space for it. Get a pointer. I got to tell the user enter something. Basically, I have to scan in what the user inputs. I terminate it because I don't want a lot of characters inside. I just want 1 or 2. I should have just made like 3 or something. It doesn't matter anyway. I'm cutting it off after 2. Okay, so buffer 0, buffer 1 are allowed. Buffer 2 is going to be a string termination. It's going to end there. And then I stir copy. Stir copy stops at this guy, right? So I string copy from buffer into the item, and then I insert that item into my BST. Okay. All right. And then what I'm going to do is just print the BST so that everyone can see. And when I print it, so let's do a print the BST and then in order. Okay, we're going to do an in order traversal of the BST. So what I'm going to say is print f. Okay, and then I got to tell the user what I'm about to do. Printing the BST in order. Okay, and then \n. And then I call BST print. And here, so BST print, that's the problem. So if I go in here, BST print, I guess I could look. Where's BST? BST print needs a pointer. So what I could have done was I could have made a print function. I could do that still. Instead of get root, what I could do is I could go in here and just go void print, right? And then that's it. I don't need to pass anything. I could do that, and then I could say I could call BST print with root. I could do that, and then I don't really need this guy then anymore, right? I don't really need the get root function. So if I do that, but I need to declare this. If I'm going to do this, I got to go here, go to treefunc.h, and now here BST print. I should, just like I did before. Yeah, is that even allowed? Let me see. It should be because it's a capital P. Yeah, should be. This should be allowed. So then what I can do is I can go here, and instead of going BST print, I could just call print. And this should print, Control S, this should print the BST, print the contents of the BST. Control S. Okay, so that's it. What I could do, another thing I could do, so let's test this and see if it all works. If there's any issues. There was a P in there. How many would I want to put? Let's go 5. So this is going to be F. This is going to be B. This is going to be A. This is going to be C. It's going to be D. A, B, C, D, F. Yeah, it's in order, right? You'll know that it'll be in no matter what order I put the items, it's going to be printed in alphabetical order, and so that's good. So what was the issue here? Was there any other issues? No, this looks fine. Okay, so that's fine. I want to test. What else do I want to test? I want to test. I did the BST init. I haven't put. Let's see. Fill the BST. So I got that. Buffer copy the buffer, and I used the insert. So what other things? Did I test all the functions? I could call height. I could call count. Oh, you guys can do that. Let's see. Searching for the last inserted item might be something that you might want to find here. You guys can do the rest of the stuff, but let's go print the BST. No, I want to print the. I want to search. Search BST for the last inserted item. Let's say. Okay. So I'm gonna tell the user that that's what I'm doing. So searching the BST for the last inserted item. \n. So if search, I gotta find out what's in buff, right? Okay, so I'm searching for dot buff. Okay, so what does that mean? It means I'm looking for this guy right here. Okay, I'm searching for that, and I'm looking for, so this search is going to return the actual item. Okay, search returns the item, and if you go, so this returns the item, and this gives you a dot buff. So that tells you if there's something in there, right? Then you print it. This will be the last item at the root, right? So print f. You can put. You can say. So here, \n found last item in the tree, \n, and then basically you're telling them that you found it, right? You could tell them what it is. So you could say %s, and then you could go. You could search it again, or you could say. Well, we could. I don't want to do it again. I could store this into a buffer. Could do that if we wanted to. Search it again. Copy. Okay, I'll just do it again, just for the sake of keeping it simple, and then that's it. And else. What's wrong here? What's the issue that it said? Do you reference the null pointer p? Let me see what I want to do. Oh, it's probably having an issue from there. What I also forgot was I need to free. I do need to free the tree at the end. Okay. I have to free the root. Otherwise, that memory is just going to get. Let me run this for a second and see what's going on with this. What's the error causing? Okay, I want to put in 5 things in the tree. G, E, J, K, A, E, G, K, J. Good. The found last item in the tree, that was A, and it's A. Good. Done. Okay, so I hope you learned something from this. It's certainly going to help you with your assignment. And yeah, so anyway, have a good rest of the day. I hope you enjoyed this.